NASA, in cooperation with other national space agencies, has identified lunar regolith dust as the principal limiting factor in returning to the moon as part of the Artemis program. Jagged, charged, and potentially toxic dust particles from the lunar environment cling to surfaces, degrade the structural integrity of parts, and contaminate life support systems. One major transmission vector of the dust is extravehicular activity, or EVA. When astronauts return from EVA sorties, accumulated dust on the suits is brought back into the lunar habitat, endangering the health of the astronauts and contaminating the interior. Actively limiting dust buildup on EVA suits is an effective way to mitigate the risks posed by the regolith dust. To combat dust accumulation on the gloves of the Artemis XEMU suits, SSPL proposes the Active Electrodynamic Glove Integrated Shield, or AEGIS.
The Electrodynamic Dust Shield, or EDS, is an active dust mitigation technology. An electrodynamic dust shield is made from a multi-layer dielectric coating with an embedded electrode grid. The electrode grid runs a multi-phase AC signal which creates a non-uniform electric field. This electric field polarizes dust particles, leading to an induced dipole moment. The electric field then pushes these charged particles away from the electrodes, cleaning the surface.
AEGIS is an EDS system with carbon nanotube electrodes embedded in the outer layer of an XEMU glove. Upon activation, AEGIS will repel and remove dust from the XEMU. AEGIS can remain active for the entire duration of the EVA, or can be turned off at the astronaut's discretion. When the EVA is completed, the astronaut will power off the AEGIS system and store the XEMU suit normally.
The AEGIS team chose to use carbon nanotubes as electrodes because of their strength, flexibility, and efficiency. Carbon nanotubes are 30 times stronger than copper wires and are more effective at dust mitigation, achieving between an 80 and 96% efficiency rate. This choice of electrode material maximizes the efficiency and minimizes the risk of wear and tear on the suit.
AEGIS will consist of three major components: a control unit, a glove interface, and CNT electrodes. The EDS controller will take inputs from a glove interface to control the voltage sent to the electrodes through a three-phase inverter circuit. By varying supplied voltage, the user can directly manage the electric field strength emitted by the glove.
SSPL is an undergraduate research lab involved in multiple aerospace and electrical engineering projects, the most recent of which was OASIS, a rover-mounted spectroscopy instrument developed as a finalist in the 2020 NASA Big Idea Challenge. ILC Dover, NASA's spacesuit supplier since the days of Apollo, and DexMat, an innovative carbon nanotube manufacturer, support AEGIS and have expressed great interest in collaborating on the project. These relationships will be crucial to the development of an EDS system well integrated into the XEMU suit and that utilizes carbon nanotube technology to its fullest potential.